All right. So implicit differentiation is used when we can't make something into y equals. So it's got x's and y's meshed up together, which causes a lot of problems. When we try to make it y equals, we end up with something that's really disgusting to differentiate, whereas implicit makes it quite easy. So we know that dy by dx means what?
Differentiation of x differentiated in terms of y.
Nearly.
Y differentiated in terms of x.
Good.
I did my best.
And you were on the right track. So we're looking for the x's in something to differentiate. So the question is, if we had something where there were x's and y's muddled up in it, for instance, what is this? Oh. Does anybody know what it is? Good, it's a circle. All right, so we've got x's and y's. We could rewrite this. We could go to the point of saying, okay, y squared equals 9 minus x squared, and therefore y is equal to the square root of la 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 la. All right, so this is actually not too bad a one. But we could also differentiate this in bits. And by doing it implicitly, what that means is that we are going to look at each bit and do one bit at a time. But every single bit we're going to do in terms of x and in terms of y. All right? So when we differentiate this one, we're going to do it in terms of x and in terms of y. In terms of x and in terms of y. And even this one, x and in terms of y. So each term is differentiated twice. Once with the x's, once with the y's. So if we differentiated this one, we would get 2x. Good. All right. This one, when we come down this line, it says, what are the y's in this differentiate to? 1. Or there aren't any y's. All right? There is 0 y's. So x squared in this case is just a constant. It's not a variable. It's just a there thing. So this one would differentiate to 0. But the difference here is that because we're differentiating this with respect to y, we're going to write that it's dy by dx. All right? So we differentiated this in terms of x, even though it has y's in it. So we continue on and we say, okay, what happens to this one when we differentiate this one in terms of x? 0. No dy by dx. Just drive that one around the corner a bit. No dy by dx this time because it was a y. All right, and we were doing the x one. The x ones don't have a dy by dx, only the y ones. So if we now differentiate the y's, what do we get? 2y. 2y. dy by dx. So we've differentiated y with respect to x as though it's a y. With respect to y as though it's an x. And when we differentiate a constant, we get 0 both times. So 0 here and 0 here. So getting rid of all the zeros, what do we have left? We've got 2x plus 2y dy by dx equals 0. But when we differentiate, we're trying to get to this. So we need to rewrite this as this. So we've got 2y dy by dx is equal to negative 2x. dy by dx is equal to negative 2x over 2y. Or negative y over x over y. So that's our gradient function. And that will change as we go around the circle. All right? So it's a bit of a weird one. And we have to do it slowly. Looking at another example. If we've got ln of y plus xy equals 2. All right, again, we need to differentiate. We don't need to worry about this one because we've got the idea here that constant vanishes. So we need this one with x and with y, and this one with x and with y. All right, so when we differentiate the x of the first one, when we differentiate this in terms of x, we get 0 because there are no x's. All right, so that is just on this branch here, that is just behaving like a constant. So we get 0. But when we differentiate it in respect to y, we get differentiate 1 over y dy by dx. We're differentiating it. All right. Now we've got this thing x, y, and x and y are going to behave as constants at different times. So when we're looking at it in terms of x, the x is a variable, the y is a constant. So what will happen when we differentiate this? We'll get left with y. Good. We get left with the other letter. Same thing here, except when we get this other letter, we also get a dy by dx. And we get a 0. So these are all plus, all right? So we've differentiated each one in terms of. So what we've got here then is something that really looks yucky. But if we had this, all we'd have to do is actually be able to put our numbers into it. It's a gradient function. So we can just put the numbers into it. We just need x and y to put into it. But it's nicer if you rewrite it. So we're going to say dy by dx is the common factor of these two. What's left? 1 over y and x. Then we've got equals negative y. Right? So taking the y over the other side.
Why can you group the y like 55? Oh,
Right? This is a common factor.
okay, so you just move the y over so it's not part of the...
Yeah, so I've taken the y over the other side because it's not part of this dy by dx.
Okay.
Now when I want to have something that says dy by dx equals. So I actually need to play with this. Right? So we need a common denominator of xy, which gives us x plus xy. No, x plus, actually we don't, we want a y. Change my mind on that. We're going to have just y on the bottom, which gives us 1 plus xy equals negative y. So now we're going to divide the other side by that, which means we are timesing by the reciprocal. So negative y times y over 1 plus xy equals negative y squared over 1 plus xy. So that's the derivative. And if we were finding the gradient of it, we would have to have an x and a y, right? So we'd have to have the coordinate for x and y. Up till now, when we found the gradient, we've just used the x coordinate to find out whatever we're interested in. But now we need the x and the y part of the coordinate to put into here to find out what the gradient is at that point. All right, so if we were finding the gradient, finding the equation, finding the tangent, we would need a point that is on it, which I don't know if this is on it or not, but we're going to say it is 3, negative 4. All right, so to find the gradient of the tangent at that point, which we hope is on that curve over there, we would put it into here. So dy by dx equals negative negative 4 squared over 1 plus 3 times negative 4, which equals negative 4 says 16, negative 16 over 1 plus 12, 1 plus negative is negative 11. So it's 16 over 11 is the gradient, if that point was on the line, on the curve, which I'm not sure it is or not.
So